The transformer windings consist of the current-carrying conductors wound around the sections of the core, and these must be properly insulated, supported and cooled to withstand operational and test conditions. This video will show you the way to test the winding of the power transformer. If it is brand new transformer or it is going to put onto service. If you are ready, let's get started. The main purpose of this test is to check for gross differences between windings and for opens in the connections. Measuring the resistance of transformer windings assures that each circuit is wired properly and that all connections are tight. Winding resistance in transformers will change due to shorted turns, loose connections, or deteriorating contacts in tap changers. Regardless of the configuration, the resistance measurements are normally made phase to phase and the readings are compared with each other to determine if they are acceptable. In the factory, it helps in determining the following. First, is the calculation of the I2R losses in the transformer. And secondly, the calculation of winding temperature at the end of the temperature rise test of the transformer. These are our base for assessing possible damage in the field. Talking on the I2R losses in power transformer. Although there is a lot of testing equipment nowadays that will execute as a low resistance test set. But the same concept of the test method they employ. The method of connections depends on the wiring diagram of each test instrument. And one of these is the voltmeter-ammeter method is used for measuring the winding resistance of each terminal and/or each tap point. The testing currents do not exceed 15% of the rated current of the winding whose resistance is measured. Avoid testing at greater than 15% of rated current since this may cause heating which will affect the accuracy. Typical test currents are 1 to 15% and using 5 to 15% will give fast and stable readings. Just like in this example of the power transformer. Having a delta-connected primary winding and Y-connected secondary. A low resistance test set is connected accordingly. Where the current to be injected is DC not exceeding 15% of the rated in the transformer, possessing an internal voltage channel to determine the known winding resistance. Voltage DC input measures the voltage generated at the transformer winding. From that value, the winding resistance is calculated. As a basic test exhibit in this video, the current interpolate to H1 H2 and XOX2. Please be mindful that analogous tests carried out must never open the measuring circuit while the current flows. Dangerous voltage may occur. Nevertheless, there are test instruments that are capable of one system for multiple tests alike. Just 3 cables need to be connected to perform various tests, especially the DC winding resistance test. Another important item to take into consideration is the winding temperatures at the end of a temperature test, which is very useful to coincide with the reference standard IEEE 57.12.90 Clause 5 that we are using. The examining values convert to 75 degrees Celsius, where the formula is as follows. Rs is the resistance at desired temperature Ts in ohms. T is oil temperature as measurement. RT stands for the measured resistance at T. Ts equals to 75 degrees Celsius which is our desired reference temperature and for constant copper temperature equals to 234.5. Although they are also testing sets, measured values will be automatically corrected to the reference temperature. And the only need to do is to input the reference value as customer-defined inline to which standard and what type of material being used. As a piece of additional information, the temperature differential between the top and bottom oil temperatures shall be measured with thermometers, and shall not exceed a 5 degrees Celsius difference. The winding shall be under the insulation oil with no excitation or current in the winding for a period of at least 3 to 8 hours before the cold resistance is measured. Now looking at the sample test 3-phase, 33 MVA power transformer 60 Hz having 67 kV to 23 kV secondary. The winding resistance is measured as shown, in each tap position and in every phase of the primary winding. Readings are established as the instrument stats on testing until stabilization of current A. HV side resistance R1. LV side resistance R2. Then record the examining values for each phase, and tap. But then again, depending upon the test instrument that will automatically show the examining values and export them to the specific file type, including the mean or average value and converted standard winding resistance. These mean resistance values came from the 3 winding resistance measured by the tester. Primary side in each phase A. Phase B and Phase C. Since the temperature during the test performed such reading, the formula from the standard is being used to exhibit from the past results, and examining the determinant benchmark value and the mean value that have an equilibrium tolerance of plus and minus 3%, which is specified by the transformer manufacturer. In these results, the percent balance shows that the transformer has less than 3% inside of which is considered as a past transformer winding. Another way to examine the trend result from the past is to compare the recent graph, if it has any distinction on the trace chart. If there are contrasts, it could be due to shorted turns, loose connections, or deteriorating contacts in tap changers. But mostly human connection errors that occur especially when the transformer has not experienced any major problems. Depending on the type of design of OLTC that uses a selector switch that chop and change the connected winding of the transformer, will manifest the graph figure. Just like in this example. Unlike with the first chart that creates a straight line to the last tap position of the OLTC, this one has a V-type chart due to the change switch selector that diverts back to the same winding but discrete tap. Just be reminded, this current voltage method of measurement of winding resistance of the transformer should be repeated for each pair of line terminals of winding at every tap position. Measure the resistance of each winding at the rated and extreme tap positions and compare the results to the original value in the factory test report. If the tap changer connections have been made at site, measure resistance at all positions. Do not attempt to measure resistances using a contact resistance microohmmeter. A safety hazard for operating personnel occurs when the inductive charge created by the windings arcs across to the leads as they are withdrawn away from the windings. Hope this video will help you in your upcoming test. Thank you. See you on my next vid.